Well, the observatory was built and erected in about 2004. It was actually a student project, so we have a sturdy built building, and after that happened, all the renovations inside, as you'll see probably in a little while, and the dome and things like that, that was all constructed by students over the years from about 2003 to 2004. And then we installed the telescope in October of 2004, and it's been open ever since. The telescope there that we use is what they call a Schmidt-Cassegrain telescope. Most of the focusing is done by a mirror in the back. When you say 16 inches, that means that's the sort of the diameter of the lens or the mirror that people use. Telescopes are big light buckets, so we're looking at dim objects, so literally in this case size does matter, so the bigger the better. And it's on a fully robotic mount, so what it is actually controlled by computerized control so that we can go from one place to another. And in fully robotic mode, we could give it a list of objects, and it could go automatically from one to the other without much maintenance.
The telescope, housed at the darkest spot on the campus of Eastern Illinois University, is used by both faculty and students of the physics department, who primarily conduct research once they've learned the basics of how to operate the scope and its computer software.
Once they're sort of trained up, they can use either that telescope, or we also work with Bob Holmes, who has a private observatory about 12 miles outside of Charleston. And the students can get trained up and do research on his telescopes, which are even bigger than the ones on campus here. So they do research mostly on things like finding what they call NEOs, near-Earth objects, things that can sort of smash into Earth and send us the way of the dinosaurs, basically. And that's the primary work we do, and we're looking at, first things first, just finding and identifying orbits, right? And then some of the students have also just recently started a project to try to measure the rotation of these.
One of those students is Hannah Tanquary, who says one of the best things about having access to a telescope on the university campus is being able to get the hands-on experience.
It's really kind of satisfying when you push a button and you can hear it up there just moving, and it's neat. Myself and a few other students, we do astrometric work, and we also do photometric work on asteroids. And the majority of the astrometric work we do on the 16-inch telescope. It's a bit smaller than the 30-inch and some of the other telescopes that Bob Holmes has. So we do the astrometric work. That's basically what Dr. Conwell was talking about, where we take pictures of asteroids and we basically pinpoint their positions, which then we can give that data to the Minor Planet Center, and from that data they can better calculate their trajectories. And so that's the astrometric work, is basically just finding asteroids and knowing where they're going and what they're doing.
Whether the students are working with EIU's telescope or with those at the Astronomical Research Institute, the privately run observatory outside of Charleston on Bob Holmes's property, all of their data is put to good use.
He takes so many photos that through the University of Chicago, he has and Yerkes Observatory, they have an educational outreach program where students, like the students at Eastern, but also high school students, can actually take this worldwide and analyze the photos as they come off nightly. And if they do the measurement and find something new, they get credit for actually making a new discovery published at the Minor Planet Center at Harvard. So worldwide, any measurements done by what they call minor planets, asteroids, comets, things like that, once we accurately do those measurements, we report them to the Minor Planet Center, and anybody can access those. Those are all totally online.
So you may be picturing students standing with their eye up to the telescope's eyepiece as they conduct their research. But as Dr. Conwell told us, that's only the case once in a while for some special occasions.
Most of the time, when we use it, we're not actually up there looking through an eyepiece or anything like that. That's a common misnomer. Nearly all the time when we're using it, we have a camera. But about once a month, on the last Friday of every month, right, we have an open house for the public where we take the camera off, put an eyepiece in, and it's rain or shine, so if it's not raining and it's clear, you get to look through a nice big 16-inch telescope at whatever happens to be out that night. And even if it's raining, you can always come by and not look through the telescope, but at least look at it, and we'll let you rotate the dome.
Getting to look through a telescope like this is a rare treat and quite a world apart from the experience you might have with a telescope at home or from simply stargazing with the naked eye.
Without a camera, this thing will pick up roughly 600,000 times dimmer than what you could see with the naked eye. With a camera, right, you can actually see a lot more with the camera. You could see things, if you look through the monitor, 8 million times dimmer than what you could see with the naked eye.
And generally, the reaction to what people see the first time they step up to the telescope's eyepiece is the same.
The first time they look in the telescope, especially if we're looking at Jupiter or something, they just say, wow. And the one thing that is my favorite is, and especially little kids will say this, they'll say, it's so real. Like, they've seen pictures in textbooks and stuff of Jupiter and of the moon and stuff, but when they can actually see it, like, they're looking at it, it's there right now, they're just like, it's so real, it's really there. Like, that's the main reaction that people get that I think is really cool.